Hi everyone, so welcome to this video. So in this video we're gonna be solving this computational problem. So the problem statement is we'll be given a circular array of non-zero integers. So what is a circular array? So the circular array is if you start traversing from the first element of the array, when we reach the end, will basically traverse or travel will be wrapped across the opposite end. So when we start traversing with the first and when we reach the last element, then the next element which we gonna be pointing to is the first element. And similarly, when we start traversing from the last element all the way to the starting element, so the element which we reach after the first element is the last element of the given array. So it means that the given array starts and ends at the same point. It can be either start index or the last index, or it can be the any index between the starting index and end index. And so basically we'll be given this circular array, and this values of this array basically represents the number of steps forward or backward. So if the value is a positive, then it means that uh, it means a forward movement. If the value is negative, it means a backward movement. Yeah, so basically we'll be given this array which is circular and where each value represents a movement, either forward or backward. And we have to write an algorithm to identify whether the given input circular array has a cycle or not. So what is a cycle? So the cycle basically means, so it must be a loop. So it should be in one direction, either it should be forward or backward, and the sequences or the values in the given in the loop should end and start at the same index, and number of elements in the sequence should be at least two. So then we can say that the sequence is a cycle. So basically our algorithm, we have to write an algorithm which determines whether the given array is has a cycle or not. So let us understand the problem statement better by examining these four examples. So in the first example, we can see we have an array with the values 3, 1, and 2. So if we start from the index 0, so it has a value of 3. It means that we have to do a forward movement of 3 steps. So if we do a forward movement of 3 steps from 0 to 1, 1 to 2, and 2 to 0th index, since it is circular. So basically we'll be in this loop uh, in, for an infinite time when we start from the index 0. So we are in a loop. So it means we satisfy the first condition. The sequence starts and ends at the same point, which is the index 0. But the second index is not validated. Is not valid for this when we start from this index because the sequence only contains one element. That's why this is not a valid cycle. So now if you start from the index 1, so it has a value 1. So basically we'll move to the index 2. So in the index 2, the value which we have is the value 2. So from here we'll make one step to reach index 0. From over there we'll make another step to reach 1. So basically we have started from index 1. From index 1 we have went to index 2. From index 2 we have to two steps in clockwise to reach the index 1. So we have been in a cycle. So basically this index 1 and index 2 are a part of cycle. So then the output of our algorithm for this input array should be true. Similarly, if we take a look at the second example, over here the value in the index 0 is minus 2. From minus 2 we'll take one step counterclockwise to index 2. From it again we'll take one step counterclockwise to reach index 1. So our index 1 we have value minus 1. So we'll again take one step back in counterclockwise to reach index 0. So when we start from index 0, we have reached index 1, and from index 1 we have again reached index 0. So basically the sequence contains 0 and 1th index. So and we can say that it starts and ends at the same point because we reach from 0 to 1 and from 1 to 0. So the sequence contains two elements, index 0 and 1, and the loop or cycle is in one direction, which is counterclockwise. From 0 we have to take counterclockwise to reach 1. From 1 we have to take counterclockwise movement to reach index 0. So the output of our algorithm is true. Similarly, if you check that example over here, at index 1 we need to take two steps to reach index 2. From index 2, we have to take a one step in counterclockwise. From index 0, we have to take clockwise movement. From index 2, we need to take a counterclockwise. So there is a change in direction. So there is no cycle with this index 0 and with this index 2. Now we start from index 1. So when we start from index 1, we will take a one movement in the clockwise to reach index 2. When we are in index 2, we need to take a counterclockwise movement to reach index 1. So the movement changes. So we can say that the index 1 and 2 are not a part of a cycle. So if we go to the index 2 now, no, there is no need to check index 2, but let us examine that as well. So if we are in index 2, we need to take a one step backward to reach index 1. From index 1, we need to take one step forward. So there is a change in direction. So this is not a valid cycle. So now, if we check the last index, which is index 3, we have to take two steps backwards to reach index 1. From index 1, we need to take one step forward. So there is a change in direction. So there is no valid cycles possible with index 3 as well. So since there is no valid cycle for the given input array, so the output of our algorithm should be false. So similarly, we can check it for the last example as well. So this is what the problem statement is all about. We have been given a circular array where each value of the given array represents the number of steps forward or backward. So for this array, we have to check, our algorithm has to check whether there exists any cycle or not. Yeah, so we will be solving this problem in two approaches. So the two approaches, the computer program is almost the same. There is a very little differences between these two. So the idea of approach one. So the idea of approach one is to check whether there exists a cycle or not, right? So we'll start it by from the first element. So we'll start whether there exists any cycle in the portion right to the first element of the given array. So, if you are able to find a cycle, we'll return true. If not, we'll return false. If we are unable to check all the elements right to the first index, then we mark the verified indexes by marking it as 0, and we move to the index till which we have checked. So and then from over there we'll be start checking again. So this is the idea of this approach. So now we'll convert this algorithm which we have discussed into a computer program. So I have written the computer program for the algorithm which we have discussed in Java programming language. So here, basically first we'll start by iterating through the given array. So for every element which we are being traversing inside the loop, we start traversing from the index which we are currently at as per the value written by this expression called index plus array of value of the array in the given index. So what does it do is basically, as we have discussed, the value of a given array represents the number of statements, number of steps it should move forward or backward from its current index. So when we are at index called index, so the number of steps it should we have to move is the value given by array of index. So it can be positive or negative. So basically, this expression tells us the index which we have to be pointing to from this after this index called index. So in for every element, will from every element will be moving. Uh, will be moving to the index position given by this expression index plus array of index plus 1. So, along with that, since it is a circular array, when we reach either ends of the array, we'll move around to the opposite end. So, for every loop, we'll be moving to the we'll move to the index position. We'll continue move to the index position given by this expression called index plus array of one. So we do this. We continue this movement until we find a change in direction of movement, or else if we have found a sequence of two indexes again, it means that we are in a cycle since we have been to the same index, same consecutive indexes again, or else if you are stuck in a loop index. So the first and second condition, what does it says is, since we have discussed, we'll start by checking whether there exists a cycle in the position right to the first element, including the first element. So in the first and second last conditions, we basically will fall under the third criteria, over where we will be unable to check the whole right hand portion because we have already found a direction of movement change, so we'll stop the algorithm. So already we have been stuck at an index, so we stop the algorithm. So in these two scenarios, we'll basically mark the verified indexes by marking it as zeros. Then we move to the index till which we have checked it, till which we know that there is no cycle, and we do start checking from there. So, whereas in the second scenario, where we have reached the same indexes again, we are able to find that we are able to find a cycle. So we'll be returning true. So this scenario falls on first condition. So after if we able to if we able to find in none of these three, we will be returning false, which falls under the second condition. Yeah, so this is the algorithm to computer program. How we do the algorithm, convert the algorithm to computer program. So if let us examine the computer program which I have written, which is written in Java programming language. So this is the main method or the core method of this algorithm. So the method name is circular array root, which takes the input as an array. So over here, first we are checking whether the length of the given array is less than 2 or not. So if it is less than 2, it means that if the array has one element or if array is empty, we'll be returning false. Since if there is only one element, so we need since we need a loop or cycle of more than one element, right? So there won't be any valid cycle possible. So this is the case for even on empty array as well. So that's why we'll be returning false. And then, as we have discussed, we start iterating from the first element till the last element of the given array. So for every index we start traversing the given array from the index which we are currently pointing to till till we have found a change in direction So for every index, initially we'll be noting down the initial direction. So if value is greater than 1, if it is forward, and if value is less than 0, it means that it is a backward movement. So after we note down the initial direction for every given index, so then we'll start moving to the index given by this method called move the pointers. So this logic will basically we'll discuss it after we discuss this logic in this method. Yeah. So first we'll keep on moving to the index given by this method. So we have a loop while true, and inside this we have been moving the index, and then we have been checking if the given index is in this set hash set or not. So over here, basically, I have been using this hash set to store the already visited indexes. So if I have been already to this index, I'll be checking whether it is there or not. If not, I'll be adding this index. If this index is not already visited, I'll be adding this index to this hash set. So that whenever we come to this index next time, uh, we'll be moving to the next index again. So since here we can see after I move the index, so I have been checking whether it is in the hash set or not. If so, I have been again moving the index since we need to have a sequence of at least two in a cycle. So if we if the both indexes, if after moving one step, if the index is in hash, if we move the index, if the next index as well is in the hash, then it means that we have been to this sequence of two indexes again. Hence it says that we have been in loop. So we'll be returning true. Along with that, we'll be checking whether we are stuck at an index or not. So we'll store the previous index. So and we have the new index. If both are not same, it means that we are not stuck at an index. We are not in a single element loop. So we'll build return true. In the other hand, if you are in the single element loop, we'll be breaking this inner loop and going to the next element and checking whether there exists a cycle the writer portion of that element or not. And then at the end, we'll be marking. So since we have been storing the visited indexes, right, in this hash set, so we'll be marking the values at these indexes as 0. So since we have been already to these indexes and we have not reached this statement written true, it means that these elements are not part of a cycle. So if one of these index is part of a cycle, we would have already come here and written true. So since it is not so, we'll be marking as 0, such that next time when we reach here, when we start moving the indexes, so we'll come here or where we have been, we'll be in the single element loop, right? And we'll be breaking. So this will essentially save us some time, right? So if we have been again to the same element from a different, starting from a different indexes which we have not been there. So if it is not 0, we'll again go through these. We'll again move the index to the next position and do the checking, right? On the other hand, if it is already marked as zeros, we'll be doing a single element loop from over there, and then we can save the time of the logic over there, right? So that's why we have been marking as 0. Yeah, so this is the computer program for this algorithm. So over here, basically, essentially, we have two portions in this algorithm. So the one portion over here is starting from this given loop. So starting from this int index equals to 1 all the way to this end of this while loop. So over where basically we have been moving index given as per the logic by this move the pointer method, and then we have been checking whether there exists a cycle or not. So if yes, we'll be returning true. If not, um, if you are unable to check the whole right hand portion, we'll be marking the indexes which we have already visited as zeros, and then we'll be going to the next element and checking whether there exists a cycle or not. So this is the same logic as we have discussed when we have been earlier discussing this example. So right, so when we start at index 3 we be in a single element loop, since it has to make three steps which will essentially reach to the same element again. So we'll be moving to the next element. We'll be checking whether there is a cycle by moving one step forward and two steps backward to reach the element one again. So since it is possible, we'll return to. So that's what we have been doing here. We have been taking a loop. So over where we have been checking whether there exists cycle or not. So, so to check the cycle, we have been verifying whether we have reached a sequence of two indexes again. So otherwise, we have been stopping. We have been breaking whenever we found a change in direction of movement, or else if we have been stuck in a single element loop. So in that cases we'll be marking the already visited indexes as zero to save the time by redoing the logic again. Yeah, so and then we'll be moving to the next element and check whether there is a cycle or not. So if we go to this move the pointer method, or where basically which counts the movement of the pointer, right? So it takes two variables. One is the an integer, and other is the array, given array. So basically, the integer first parameter, which is an integer, is the pointer. So the index of the given number. So the method will be taking this integer and the array, and it has to. This is the current index which we are currently at. So we have to move to the next index. So as we have discussed, so I'll be assigning this variable a to a variable called prev, let us say, and then I'll be moving this a pointer to the value given by a plus nums value at eighth index. So basically, there is a chance that we might have reached outside of the of the given array, right? So since we have been adding the value, we have been moving forward or backward as per the from the current index as per the value at that element. So there is a chance that we reach outside of the indexes of the given array. So in that case, will be at an index either which is greater than n, or index is less than negative, less than 0, which is negative. So since array is circular, it should not be possible. So since to move through this circular array, so we need to essentially after we move as per this move to the index as per this expression, we need to do some certain changes. So the changes are, so since let us understand it by examining these examples. So here we have an array which has values minus 7, 1, 2, 3, 4. So over here, the A is 0. So A is the point index which are at currently. It is 0. So n is the number of number of elements in the given array, which is 5, and the value at index 0 is minus 7. So now, basically the A plus the summation of A plus value at 8th index, which is 0th index, is minus 7. So we are at minus 7th index. So it means that we are outside the index of given array. So now we'll basically check the remainder of this minus 7 across n. So which basically tells us how many steps behind the first element of the given array which we are currently in. So if we do minus 7 and 5, the remainder is minus 2. So it says that we are two steps behind the 0th index. So since it is a circular index, so we need to go to n minus 1th index from 0th index, and from n minus index we need to take one step. So it is like we have got two steps backwards. So that is what we have done over here. So whenever a is less than 0, so we'll be taking one step to n minus 1, so which will essentially will be at essentially at n minus 1 index, and over there from over there we'll move to the left side k minus 1 times. So over here k is the remainder of a plus nums of a and n. So that is the final position of our eighth pointer since we are in a circular loop. Similarly, if we take this example where we have an array of values with 4 ones and followed by value 4. So over here, when we are at the last index, which is the index 4, so the a plus the value at fourth index will be 8. So which is essentially greater than n. So n over here is 5. So the last index is 4, but we are the value written by this expression is 8. So we'll check the remainder of a plus nums of a plus 1 and the index and the value n. So since the position is nothing but the index plus 1, because the element at first position is the element at index 0. So that's why we have added a plus 1 over here. So the value is the remainder is 4. It says that we are essentially 4 steps ahead of the index at minus 1. So we have to take one step to the 0th index. From over there we have to take 3 steps. It means that we have to take k minus 1 steps. So that is what we are doing over here. So whenever a is greater than equals to n, we have to take k minus 1 step. So this is how the pointer moves. Whenever we reach outside the given array, so we'll essentially traverse around to the opposite end by following this expression. So whenever we have reached the behind the first index, so it means that we'll be the index which will be next is like n minus 1 minus k minus 1. If we have reached outside the right to the last index, so then we'll be at the index k minus 1, and at the end we'll be returning here. Yeah, so this is how the moment pointer movement works in a circular array. Yeah, so this is about the approach one, where we have essentially looping through the all elements and checking whether there is any cycle possible in the right hand portion of the given array. So if so, we'll be returning yes. If you are unable to check the whole uh, right portion, so we'll be marking the already visited indexes by marking it as 0, and then we'll be checking the indexes which we haven't visited. So if possible, we'll be returning true. If not, at the end, we'll be returning false. So this is what this approach. So as we have already talked about this computer program, so we can optimize this computer program into this. So here the same first will be if a number of elements is less than 2, will be written false. And then same will be taking a loop all the way from first element to last element, and we'll be moving the pointer using by following the value given by this method called move the pointer, and then we'll be continuing doing so until we found a direction change, which if we found a different direction of movement rather than initial direction, or until we are stuck in a single element loop, or until we found a cycle. So, so if we found a direction inconsistency, we'll be breaking and we'll be going to the next element. If we are stuck in a single element loop, so again we'll be breaking and we'll go to the next element. So in the end, if we have reached the same element again without going through a single element loop and without a direction change, it means that we are in a cycle. So we'll be returning true. At the end, if none of these three, then we'll be basically adding this index to this set. Basically, we are maintaining this set to maintain the already visited indexes. And at the end, we are marking the values at the already visited indexes as zeros. So to say, which will be essentially save up some time for the given logic. And at the end we'll be returning false. So this is the optimized computer program of the algorithm which we have discussed. Yeah, so this is what is approach 1. So now we'll be following approach 2. So which is essentially a fast and slow pointer algorithm. So whenever a problem comes, any cycle or loop detection problem comes, so we'll generally follow this fast and slow pointers approach. So over here as well, the basic idea is same. We'll start by checking. We start whether there exists a cycle in the right hand portion of first element of the given array, including the first element. So we'll be returning true. If not, we'll be returning false. If you are unable to check the whole right hand portion, we'll be marking the already visited indexes with 0, and we'll move to the index till which we have checked and start checking from there. So to do that, we do the same. We'll be looping through every element, and we'll be moving to the index as per the value returned by this expression index plus array of index. So we'll start two pointers, slow and fast. The slow pointer will be moving one step at a time, and fast pointer moving two steps at a time. So the moment is gone by basically gone by this expression index plus array of index, and we'll be doing this movement until we found a direction change, or until we have reached the same indexes again, which indicates a cycle, or until we have stuck in an index. So the basically the difference between first approach and second approach is how we check whether we found how we detect a moment change, or how we detect whether we are in a cycle, or how we detect whether we are in whether we are stuck at index or not. Over here in the first approach, we checked using the one pointer, Now here we'll be detecting this using two pointers. So to detect whether there is a directional movement change, we'll check whether the value at fast pointer and slow pointer is less than zero. It means that either of slow pointer and fast pointer are at different uh, uh, signs. So the fast can be at positive or negative, and slow can be either positive or negative, vice versa, or opposite sign to fast. So if you want to detect a cycle, so since it is a cycle, so the fast and slow pointers are bound to meet a point. So if fast and slow pointer is met at a point, and if the next index after the slow pointer is not the previous pointer, it means that we are in a cycle. So we'll be returning true. So the basic difference between fast and slow approach is how we detect whether there is a moment change or whether there is a cycle or whether we are stuck in an index or not. So we do check that by using the two pointers, which are slow and fast pointers. So this is a computer program for this approach. So basically this method called move the pointer, which is responsible for returning which basically takes the previous index and the array, and it returns the next index which should go to. So this logic basically same in first approach and second approach. However, this method logic is changes. So here as well, we'll first check whether n is less than 2. If it is less than 2, we'll be returning false. And then we'll start iterating from the first element to the last element. And then inside each loop, we'll be initializing this fast and slow pointers starting from the index. And we'll be also initializing a set which will essentially store the already visited indexes. And then we'll start moving the slow pointer and fast pointer one step at a time. And then we'll be adding these indexes to this hash set. And then we'll check whether there is a direction change or not. If so, we'll be breaking. If not, we'll be moving the fast pointer again. So it will make two steps in the same loop. And then we'll be adding this index to the hash set. And then we will check whether there is a direction change or not. If so, we'll be breaking. Otherwise, we'll check whether have been we have been in a loop or not by checking whether we are slow pointer and fast pointer met at the same point or not. So if fast and slow pointer met at a point, same point, we'll be incrementing. Will be a slow pointer again. Will be by one step. So if slow pointer previous position and next position is not same, so it essentially says that we are not in a single element loop, so that we'll be returning true. If not, if we are in a single element loop, we'll be breaking and going to the next element. So at the end, we'll be marking the already visited indexes as zeros, and at the end, we'll be returning false. So essentially, as I said, the core difference between approach 1 and 2 is how we detect a direction change, or how we detect whether there is a cycle, or how we detect whether we are stuck in an index or not. So in the second approach, we do all these three by using the two pointers, which are slow and fast pointers. Yeah, so this is what is all about the second approach. So basically, in these two approaches, I have two loops. One is the outer loop is going all the way from first element to last element, and the inner loop is while loop. So basically, the reason why we have two loops is to uh, So sometimes, as we have discussed, we'll be unable to check the entire right hand portion of the key of the index which are currently in. So this is because we have to stop whenever there is a direction change. So the loop should only be in a single direction, in the same direction. So whenever we encounter a, suppose if you start from index 2, so we'll move to the next index as per the value at index 2. So if suppose we move to index 4. So now if we move to index 2 again, so it means that index 2 and index 4 are not in the cycle. So now, so since index 2 and index 4 are not in a cycle, and we have index 5, index 6, and index 7 all the way to index 10. So there is a chance that there is a cycle possible from index 5 to 8, right? So that's why we'll stop over there and we move to the next index, which is index 5, and check whether there is a cycle possible or not. To do that, we need this outer loop. So in this outer loop, you can say that why are we moving to next index rather than moving to the not unvisited index. So the answer is we can't find it. So suppose over here we have, so if we check in the first approach, over here we can see that the value called next index basically has the index which we are currently in. If we have found a direction change, so you can say that why won't we go to this next index and start from there? So why we need to go to the I plus one index in the next iteration? So the point is, suppose if we are at index 2, so suppose if it has a value called minus 4, so from minus 4 we should have to take two steps. So we'll take one step to index 1, two steps to next step to index 0, and next steps to index 1, and last step to index n minus 2. So the next index value will essentially be n minus 2. So if from n minus 2, if there is a direction change to n minus 1 or 0 or 1, so in that case, we can't start checking from n minus 1th index since we have been in a counterclockwise loop. So we have to check all the way from first index to n minus 1th index. So since we have start from, sorry, from third index to n minus 1th index, since we have started from the third index, so that's why there can be a counterclockwise, or since it is a circular loop, we'll be traversing around the opposite end. So that's why we need this outer loop over where we are iterating one element at a time. Yeah. So that is the idea of two loops in these two approaches. Yeah, so this is the these are the solutions for this problem statement, or where we have found we have written an algorithm to find whether there exists a cycle or a loop in the given circular loop or not. Yeah, so I'll be leaving the link of the sheet which I am displaying over here in the description of this video. So feel free to go through it. This sheet also contains some of the other problems, which can be essentially solved using this fast and slow pointers algorithm technique. Yeah. So that's it for this video. See you in the next.